Alright, these next problems also say solve the following logarithmic equations. So we're going to be doing the same thing. These have expressions in them instead of just variables and numbers, but they're going to work the same way. It's given as a log, so I can still use my e here and say this is base 4 raised to the second power is equal to that expression x minus 2. So we just start simplifying and solving as we normally would. It's linear, so I just need to add 2 to both sides, and I get x equals to 18. Now for number 5, you notice I don't have a single log term. I have 2. So the first thing we're going to have to do is use those properties that we learned to rewrite that left-hand side as a single log. It is a sum, so we're going to use that property 1 and rewrite this as a product. So we have log base 2, and it's going to be x times x minus 1 equals that 1 on the right-hand side. And if I distribute, I get x squared minus x. So now that we have a single log, now we can use our e format and say this is 2 to the first is equal to x squared minus x. This one is a quadratic, so we're going to need to get equal to 0. So I'm going to subtract the 2, and I have x squared minus x minus 2. Now you can use any of the methods you want. You can factor, quadratic formula, completing the square. This one I believe is factorable, so I'm going to go that route, but any of those options will get you there. We're going to need -2 and +1. And then, of course, our zero factor property gives me x equals 2 and x equals -1. Now, you may remember or not that in a previous lesson we talked about the domain for the logarithm function. This is the first place where a problem or an issue comes up. If you remember, we said that the domain is 0 to infinity. So it means that what we're taking the log of has to be a positive number. Well, we just got x equals 2 and x equals -1. So the 2 is fine, but we're going to have to reject the -1, because if I plug that back in, my very first term is log 2 of x. If I had log 2 of -1, remember this is not in domain. So don't forget to be on the lookout for that. So this problem has only solution x equals 2. Okay? So number 6, of course, is similar to 5. It's just we have a subtraction. So we're going to rewrite the left-hand side as a division. So it's going to be x over x plus 6 equals 2. And now that it's a single log, we can use the e. So I get 4 equals x over x plus 6. Now remember, this is one of those rational equations. This was what I was talking about. These problems are bringing up a lot of things that we've already learned in this course, right? So my LCD is x plus 6 if I multiply both sides, I get 4 times x plus 6 equals, on this side they cancel, right? So I get 4x plus 24 equals x. It is linear, so I get 24 equals negative 3x. And if I divide by negative 3, I get x is equal to negative 8. So don't forget, we need to be careful of these solutions. If I was to put that back into my original, my first term is log 2x. So if I put in negative 8, that's not in the domain. So we're going to need to reject this answer. And since it was the only one, that means there is no solution to this equation. All right? So the last thing we're going to look at is a couple of applications of this stuff. And the first one is compound interest. So first we have to figure out what this stuff stands for, and we've talked about a lot of these before. The A is the amount accrued or owed, and I like to think of this as the ending amount. So if you invest money, the A is how much you end up with after it's been invested. If you borrow money, the A is how much you end up owing after you have to pay all of the interest and such. The P is the amount that is invested or loaned. So this is the beginning amount, or I've called it our pocket money before. R is the annual rate of interest. And remember, it's probably going to be reported as a percent, but when we use it, we will have to change it to a decimal to put it into our problem. N is how many times a year they're going to compound the interest. And if you look down here, some of the values for N, if it's yearly, then that means one time a year. Monthly, there are 12 months in a year. Quarterly, there are 4 quarters in a year. And semi-annually, halves the year, which is twice a year. Okay? And then, of course, T is time as usual. So if we're going to find the amount a college student owes at the end of 4 years, I see here T is 4. If $8,000 is loaned to him at a rate of 9%, so if I change that to a decimal, my R is 0.09, and semi-annually means N is equal to 2. So I have to decide, do I have A looking for P, or do I have P looking for A? So the $8,000 is what was loaned to him. So that is my beginning amount. So that's P. And we're looking for how much he's going to owe afterwards. So that's the ending amount. Okay? So we're going to plug this stuff in. I'm looking for A. P is 8,000. 1 plus. The R is 0.09. N is 2. It's also 2 here, times T, which is 4. This is another place where I want you to note how I am solving this problem and what I do to get the correct answer out of the calculator. Again, we do not want to do any estimation in between steps, okay? So what I'm going to do first is I entered this 1 plus 0.09 over 2 into the calculator, and you'll be able to see it better on that other page that I'm going to supply. But when I did that, I got 1.045, and that is not rounded. That's the entire number that the calculator gave to me, and it's raised to the 2 times 4 or 8 power. So from here, I'm going to enter that expression directly into the calculator the way it looks, and that's what I did in this one. And what I got out was 11376.8049. And for the rounding on this one, we're talking about money amounts, right? So cents is usually 2 decimal places. So for the answer, I'm going to say $11,376.80.